So our next problem is find the position of rightmost set bit. Okay, so what is rightmost set bit? Let's take one example. Let's say 14. Okay, in 14 we can write it as 8 or 12 to 14 and it is 0. Okay, I'm taking 4 bits for simplicity. Now rightmost set bit means this bit. Okay, it is on rightmost. It is on rightmost. I want to find the position of this bit. Okay, so if I start from here, this is first bit, this is second bit, this is third bit, this is fourth bit. Okay, so my rightmost set bit is at second position. Okay, my rightmost set bit is at second position. Now let's take one more example. Let's say 8. Okay, and it is 1 0 0 0. So my rightmost set bit is at, this is first position, this is second position, this is third position, this is fourth position. So my rightmost set bit is at fourth position. Okay, it is at fourth position. So either you have to write the mask, okay, or you have to output the position. Okay, so if you have to output the position, it will be 4. If you have to write a mask, so your mask will be, for this problem it will be 1 0 0 0. Okay, so in rightmost set bit mask, okay, if the problem is to find rightmost set bit mask, then rightmost set bit, okay, rightmost set bit should be 1 and rest should be 0. Okay, should be 1, rest should be 0. Okay, to identify which bit is rightmost set bit. Okay, should be 0. What does it means? So if in 14, if in 14 get written as this one. Okay, now I want to find the rightmost set bit mask. So what is my rightmost set bit? This one, it is my rightmost set bit. Okay, so it should be 1 and rest should be 0. This is nothing but my rightmost set bit mask. Okay, this will be used in a lot of problems. That's why I'm telling you. If you have to find the rightmost set bit mask, okay, so the rightmost set bit should be 1 and rest should be zeros. Okay, it will be zeros. And if you want to find the position of rightmost set bit, then you have to output the this position, fourth, third, okay, second. So here I want to return this rightmost set bit position. Okay, so it will be 2 in this case. Now how to find the rightmost set bit position? There can be multiple ways to find it. Okay, so let me start with the basic one. Let's take this example only. Okay, 8 only. So we have 1 0 0. Okay, 8 can be written as this. Now what I can do, I can start from here. Okay, and check if it is 1, no. If it is 1, no. If it is 1, no. If it is 1, yes. Okay, whichever bit is 1, I can return. Okay, so what I can do, I can take a counter initially. Okay, I can take a counter initially and it will be initially 1. Okay, why? Because my bit is starting from 1. Okay, so the minimum bit which can be rightmost will be 1 only. Okay, first bit. There cannot be 0th rightmost bit. Okay, so let's take the counter as 1. Okay, and keep checking from here. If it is 1, no. If it is 1, no. If it is 1, no. It is 1, yes. Okay, so every time check if it is 1, no. Okay, increment your counter. That means first bit is not set, second bit can be set. Okay, so check for second bit. If it is 1, no, increment the counter. Check for third bit. If it is 1, no. Okay, increment the counter. Check if it is 1, yes, return the counter. Return the counter. Okay, which means my fourth bit is 1. Okay, it is set bit. Fourth bit is set. Okay, this is my rightmost set bit. So how we can solve this? What I can do, I can take this number. Okay, and again I will create a mask. I will create a mask. Now how I can create a mask? First start with 1. Okay, if I take 1, okay, and take a bitwise end. Okay, take a bitwise end to check whether my bit is set or not. Okay, So 0 and 1, 0 and 1. See, if I take bitwise OR, if I take bitwise OR with 1, it will always result in 1. Okay, so bitwise OR will not be beneficial for this. Okay, now if I take 0 bitwise and 1, it will be nothing but 0. It will be 0. Okay, if it is 0, just shift your 1. Okay, just shift your 1, increment the counter. Let's say this is my counter. Okay, initially it is 1, it is 0. Okay, increment your counter to 2 and shift your 1. So let's take this. Now do this. 0 and 0, it will be 0. 0 and 1, it will be 0. Again 0. Okay, again it will be 0. So increment your counter. Okay, and left shift 1. So now it will be 1 triple 0. Okay, and before it everything is 0, right? Again do this. It will be 0. It will be 0. It will be 0. Okay, it will be 0. Again it is 0. Okay, so again increment your counter. Your counter will be 4 now. Okay, again left shift. So now it will be 1 triple 0. Okay, so again do this. 0 0 0, it is 1. So it is non-zero. It is non-zero. If it is non-zero, just return the counter. Return the counter. So what I can do, I can run a loop. Okay, I can run a loop to shifting process. And at worst, it can be run till the number. Okay, if I got rightmost bit in the middle, I can return it from here only. Okay, at worst, my rightmost bit can be equals to my number. Okay, you can argue that what if it is 0? What if my number is 0? Then I cannot find my rightmost set bit. So for that, I can put a check. Okay, if your number is 0, then you can return -1 or whatever. Okay, like this. Otherwise, there will be definitely 1 at somewhere, right? So I will take a while loop. Okay, while my mask does not equals to number. Okay, and I will check. Initially, my mask is 1. Okay, and I will check if mask with bitwise and number is non-zero. Okay, it means non-zero. Then I will return the counter. Okay, I will return the counter. It means that we got our rightmost set bit. Okay, initially counter will also 1. And in else part, what I will do, I will left shift my mask by 1. Okay, mask by 1 time and increment my counter. And at the end also, I can return my counter. Okay, this is a pseudo code, right? You can optimize it. You can optimize these conditions, right? I hope you got it, right? What I'm doing, I'm going to each bit, okay, and checking if it is 1, if it is 1, if it is 1. So whenever I get my first rightmost set bit, I will stop it there, okay, and return its position. Now there are other ways to find the position of rightmost set bit also. So let's discuss them. Okay, let's say we have 7. So it can be written as 0, triple 1. Okay, and what is the rightmost set bit? So this is my rightmost set bit. Okay, and its position is 1. Correct. Now there is an algorithm, right? We will discuss that algorithm also. Okay, but as of now, assume this is 7. If I take one previous number, that will be nothing but 6, right? And what is the binary value of 6? It is nothing but 4 to this one, right? It is 6. Now I want to find the rightmost set bit. I want to find the rightmost set bit. Okay, what if I invert this? If I invert this, if I invert 6, it will be 1 0 0 1. Okay, and if I do bitwise end of this and this, will get our rightmost set bit. Okay, let me repeat again. If I take one number less, if I take one number less, okay, and if I invert the bits, if I invert the bits and do the end of these two, do the end of these two, I will get my mask of rightmost set bit. Okay, let me do this. So it is 7. Okay, it is 0 triple 1. And if I take invert of 6, it will be 1 double 0 1. Okay, and if I do AND, bitwise AND, it will be 1, it will be 0, it will be 0, it will be 0. Okay, so this is nothing but my rightmost set bit mask. Okay, and if I want to find the position, it will be easy, right? So in rightmost set bit mask, there will be only one set bit, one set bit. Okay, so what you can do? So this is nothing but this is 1, this is 2, okay, this is 4, this is 8. In binary, we write like this, right? So if I do log base 2 of whatever mask we have, okay, whatever mask we have, we'll get the position of it. We'll get the position of rightmost set bit. Okay, so this is given, right? This is proved. A kind of this is proved. So if I take a number, if I want to find the rightmost set bit of a number, I can take one number less than it. Okay, and what it will do, it will basically unset my first rightmost set bit. Okay, so take another number. If you take 12, let's say you take 12. 12 can be written as 8400. Okay, this is 8, this is 4, this is 2, this is 1, right? Now if I take 11, 11 will be nothing but 8, 9, 10, 11. Okay, and this is 0. In this also, if I take n minus 1 number, its rightmost set will be 0. Okay, so its rightmost set will be 0. So in this, in 12, this is my rightmost set bit, right? This is my rightmost set bit. So it will be definitely 0. It will be definitely 0 in n minus 1. Take any number. Take any number. So I'm writing it. Okay, you can note it. Rightmost set bit in n will be reset or 0 in n minus 1. Okay, take any number. Let's take 6. Okay, so 6 we have 0 1 1 0. Take 5, take n minus 1. N minus 1 will be 5. Okay, so in 5 we have 0 1 0 1. So you can see rightmost set bit in 6 is this one. Okay, it is 0 in n minus 1. It is 0 in n minus 1. Take another number, take any number. Take 9. Okay, it will be 1 double 0 1. So its rightmost set bit is this one. Okay, take n minus 1. Take n minus 1. It will be 8. So it can be written as 1 0 0 0. Okay, so here also the rightmost set bit in n is 0 in n minus 1. The position at which we got our rightmost set bit in n will be 0 in n minus 1. Okay, I hope this thing is clear to you, right? Now one more thing I want to say. See, this is my rightmost set bit. Okay, this is my rightmost set bit. And if you see on the left, all bits are same in n and n minus 1. But on the right, the bits are inverted. On the left, all the bits are same, but on the right, the bits are inverted. Okay, here also. On the left, all the bits are same. On the right, bits are inverted. Okay, so on the right of rightmost bit, all the bits are inverted in n minus 1, and on the left, all the bits are same. So if I take the inversion of n minus 1, what it will do? It will again set my rightmost bit. So let's say if I take n, let's say my n is 9, it is 1 0 0 1. Okay, and I'm taking n minus 1. N minus 1 will be 8. Okay, 8 can be written as 1 0 0 0. Okay, this is my rightmost set bit. All the bits on the left are same. Okay, and right side bits will be in invert order. Right side bits will be in invert order. Okay, now if I take inversion of it, if I invert these bits, what will happen? If I invert these bits, what will happen? So it will be 1 1 1 0. Okay, and if I do bitwise end of it, it will be 1 0 0 0. Okay, so let's say I am writing the generalized form. Let's say this is my rightmost set bit in n. Okay, let's say this is n, this is n minus 1. So rightmost set bit in n. Okay, and these are all right side bits. Okay, and these are left side bits. Left side bits. Okay, in n minus 1, left side bits will remain same. Okay, and right side bit will be 0. So it will be 0 for sure. If it is 1, it will be 0. And right side bit will be in invert order. Now, if I invert this, if I invert n minus 1, so left side bits will be invert. Okay, 0 will be invert and right side bit will be again invert. So these will cancel out. Okay, and inversion of 0 will be 1. Okay, and this will be invert. So what will happen? My right side bits, see, this is my first rightmost set bit. So it means that all are zeros, all on rights are zeros. So this will be zeros only, correct? And it is set, it is also set. So it will be 1 if I do end of this. Okay, and bitwise end of these will be nothing but zeros only. Okay, this will be zeros, this will be zeros. So at the end we will have only one set bit. Okay, and that too on the rightmost set bit position in n. Okay, let me explain it again. See, this is my n. Okay, and r is my rightmost set bit. So all the bits on the right side will be zeros. That's why it is rightmost set bit. Okay, and all the left bits will be some values. And if I take n minus 1, in n minus 1, these bits, right side bits will be in invert order. Okay, right side bits will be in invert order and left side bits will be in same order of n, and this bit will be 0. Okay, this bit will be 0. So if I take inversion of n minus 1, if I invert bits in n minus 1, so my right side bits will be same. Okay, it will be zeros only, and left side bits will be invert. So it's inversion. Okay, let's say and inversion of n will be nothing but always zeros, right? You are flipping the bits and doing and, so this will be zeros. Okay, and it was initially zeros. If you are inverting it, it will be 1. Okay, it will be 1. So this bit will be set and rest all will be zeros. Okay, so that's how we can find the rightmost set bit. Okay, and from here we have same process. Okay, so let's say if it is 0 1 0 0, you can take a log base whatever number plus 1, it will give me the position. Okay, this is my number, so it is, let's say, 4. So if you take log base 4 plus 1, it will be nothing but 3 only. Okay, so that's how we can find the position of rightmost set bit. This is very important. Now there is one more way. There is one more way. Okay, I can take n and 2's complement of n. That will also give the same result. Okay, take n as an example. Okay, take 9 10 whatever value, take 2's complement of n and do n. Okay, do this as dry run, do it in dry run, you will get it. Okay, it is same like this only, same like this only. Okay, you need to identify these behaviors, which bits are inverting, which bits are same. Okay, you will get it. So this is the another way. This is my third way, it was my second way. Okay, and first way, it was my first way, this was my first way. Okay, so these are the three ways to find the position of rightmost set bit. Now come to the next problem. So my next problem is